the last thing that we're going to look at in this example, in example 4, is we're going to look at comparing data sets. Right? So we're going to start by kind of looking at a little bit of information on this page, and then we get to the next page. We're going to have a table with a lot more information, a lot more data, more different types of values that we're looking at, and we want to do some comparing of these data sets. Right, so using the information in the following table, it is difficult to decide which sport is the most dangerous. Based on the information we have been given, it looks like which sport is the most dangerous and why. Right, so what we have here, what we're given so far, is we're just giving a category of sports, and then a number of injuries. Right, so strictly looking at these numbers here, right, it appears that basketball has the largest number of injuries. So just based on this little bit of information that we're given, right, it appears that basketball is going to be the most dangerous. Right? So we're going to say basketball. Right? It has the largest number, or we could go back to the beginning of the section and use the word frequency, right, of injuries. All right, so now we're going to flip to the next page in our notes, and instead of seeing just a generic little table, we see a lot more information here about our sports. Right, so the previous table only gave us a small amount of information. This table gives us a much more complete data set to answer this question. Oftentimes we use rates or percentages, right? So in some cases we're going to use percentages. In some cases we're going to use rates. We could kind of use both in this case. But notice that our last two columns in here, we are given the rate of injury per participant. Right? So when we're thinking about these, our rates are not exactly percentages based out of 100, but they could be based out of something else, a number of events out of so many objects. Right? So looking at this then, we have a lot more information here. Right? On the previous page, we only had the name of each sport and the number of injuries. Right now, in this case, we are also given the number of participants. Not only are we given the number of participants, but we're giving the rate of injury per participant and the rate of injury per 1,000 participants. So now using this complete list of information, right, which sport is the most dangerous? We're looking at these, whether we're looking at the rate of injury per participant or our rate of injury per 1,000 participants. In both cases, this value here, this 0.5078 or this 50.78 is our highest in both of these columns, right? So that means that football is really the most dangerous, right? It's football because it has the highest rate, right, which is different from our original assumption. Which sport is the least dangerous? Right, so again, we can use these. These are in here more just because they're a little bit easier to read without all those extra zeros and decimal points. Right, so our lowest one, this is 0.00046, or 0.46 is our rate per 1,000. Right, so we're going to say bowling because it has, right, the lowest rate. In order for us to compare groups, right, the groups need to be similar. Right? When the data consists of counts, so instead of using counts and just numbers like we did in our first part of this example on the bottom of the previous page, we don't necessarily want to use that. Right? We want to use either percentages, right, which we now know how to calculate using our percent equation, or rates. Right? So when we're comparing different groups, our groups need to be similar. So if we're thinking about ways to make them similar, if we're looking at these as percentages or rates, right, they're better for comparisons because they take into account possible differences among the size of the groups, and then comparing percentages and rates is a more accurate way of comparing different data sets.